All right, so this is a quiz, chapter 2 quiz. All right, so the first one, motorist travels for 3 hours at 80 kilometer per hour and 2 hours at 100 kilometer per hour. What is her average speed for the trip? All right, so here we know average speed equal to total distance over total time. And for this trip, if you see, this guy has 2 segments. The first one is 3 hours at 80 kilometer per hour, right? And then second segment, 2 hours at 100 kilometer per hour. All right. So the first segment, we know the distance d1 equal to, you see the speed 1 times t1, right? And the second segment, and then we know d2 equal to s2 t2, right? So the total distance is d1 plus d2 divided by t1 plus t2. All right. We know that d1 is, then plug in, d1 is s1 t1. So here equal here. So equal to d1 s1 is 80, 3 t1 is 3 plus 100 times 2 hours, right? Total 3 plus 2. So top will be 240 plus 200 divided by 5. Okay, so 440 divided by 5 is 88 kilometer per hour. So it's a C. Second, suppose that a car traveling to the east, positive x-axis, all right, begin to slow down as it approaches the traffic light. Which statement concerning its acceleration must be correct? All right. So this guy travel in positive x-axis, and you meet a traffic light, so you have to slow down. Slow down means you have acceleration in the opposite direction. Okay, so that's why you slow down. If you have same direction of the acceleration, then you speed up. So its acceleration is in the negative x direction, right? Third one, 2 objects are thrown from the top of a tall building, like this. One is thrown up, and the other is thrown down. Okay, both with the same initial speed. Okay, so assume v naught here, and this v naught up. What are the speeds when they hit the street? Here's a street, right? All right, so what happened to this guy? The first one is moving up, then come back, right? Then keep going. So if you start with v naught up, and then this guy, when they come back to same height, then the speed will be v naught down. Okay, so you toss up something up, then come back with so assume here you have 20 meters per second up, then this guy move up and come down, then you reach here, this is 20 meters per second down. Okay, so this is symmetric. All right, then keep moving down, right, with this all the way down, hit the street. This guy, you see, directly you move down with this initial velocity, then keep going down, right? So when this guy go up, come down, here is 20 meters per second. Same as this guy, 20. This is v naught down, right? So they will hit the street with the same speed, right? 4. A car is moving with a speed 32 meters per second. The driver sees an accident ahead and slam on the brake, causing the car to slow down with a uniform acceleration of magnitude this. Okay, so how far does the car travel after the driver put on the brake until it comes to a stop? Alright, so for this kind of question, let's see, what do we know? We know this one. This is initial velocity. V naught equal to 32.0 meter per second. The driver says accident and put on the brake, right? So you have this acceleration is, because it slowed down, so this is acceleration deceleration, so it's negative. Okay, how far does the car travel after the driver put on the brake until it comes to a stop? So V equal to stop 0, and ask you del x. Okay, so we have several equations. The equation we should use is this. You see, V squared equal to V naught squared plus 2a del x. Okay, this is the equation we should use. So we can move around, right? So delta x equal to V squared minus V naught squared divided by 2a. Plug in 0 squared minus 32 squared, right? 0.0 squared divided by 2, acceleration negative 3.50. Okay, so you plug everything in, and what you got here will be number 4 is, this is the solution. Okay, so you see it's a negative 3.0 squared divided by negative 7. Okay, so that's C will be the answer. Number 5. The figure shows a graph of the velocity of an object as a function of time. So this is velocity versus time. What is the displacement of the object from 0 to 8 seconds? From 0 to 8. Alright, so this is what happened, right? So in the velocity time graph, area covered by this graph is your displacement. Is area. Okay, so you see, just count this area, right? The area, total area. However, if you have area below this this line, this area is negative area, because negative displacement, because you move back actually. Okay, because velocity is negative, so you move back. So this will be the negative displacement. All right, so just let's count the total area. Okay, so you see, total area is this area plus this, so this area. What is this area? So this is 2, x-axis 2 seconds, vertical is 20. All right, so because it's a triangle, so half 2.0 times 20, right? So this is 20 meter. So this will be this part of the 20 meter, and this area, right? This area is this is 2. This length 2, height is 20. Okay, 2 times 20 is 40, and this is rectangular. This is 40, and you can tell same thing this area, right? So this is 2 times 20, and half of that. So this is 20 meter. And look at this area. This is 2 times negative 20. So this will be 2 negative 20 divided by 2, right? So there'll be negative 20. Okay, so you add all of them together. 20 plus 40 plus 20 plus negative 20. Okay, so this area actually is a negative displacement. So total will be 40 minus 20 is 60. Okay, number 6. Number 6 here is an airplane increases speed at the average rate. So this average rate is acceleration. Okay, how much time does it take to increase its speed from 100 meter per second to 160? So we know V naught equal to 100 meter per second, V equal to 160 meter per second. And you're looking for time, how long that take, right? So we use this equation, V equal to V naught plus AT, and looking for T. So T equal to V minus V naught divided by A. Right, V equal to 160 minus 100 divided by A, 15. Okay, so this equal to 40 divided by 60 divided by 15 equal to 4 seconds. so about 4 seconds. 7. An object is moving with constant non-zero velocity in the x direction. The velocity versus time graph of this object is the velocity versus time graph, right? So this is the velocity versus time. An object is moving with constant non-zero velocity. What does it mean? This means constant velocity, right? Constant, which means velocity doesn't change. So either this one or this you see doesn't change. Okay, so this one is a positive velocity, this is a negative velocity. Alright, so it is a horizontal straight line because this guy doesn't change. Okay, 8. The slope of a position with time graph gives, okay, so this is a position time graph, right? So anyway, the slope, right? So this slope graph, slope of a position time graph give you slope. Slope at any point give you velocity. Okay, so it's this one. Slope of a position time graph is the velocity time graph. So slope give you velocity. All right.